Okay, folks, thanks for watching my video and getting ready for the test. This is a function because we could draw a line, and let me show you what I'm talking about. We could draw a vertical line. Let's make it kind of this orange color if it lets me. Oh, yeah. And anywhere I move that line, it would cross the function, that black line, it would cross it in only one spot. What does that really mean? It means for this particular x value where I just landed the line, there's only one y value right down here. I could move it over here. For this particular x value, there'd be a y value right down here. If I moved it over here, there'd be a y value for that particular x value. Only one y value too. See, it's going to cross that line, that black line, in only one spot. So this is the test. Like visually, could I move that line anywhere and it only crosses the line, the black line, in one spot? Yeah. So if a function is, just increasing like this, constantly increasing, that vertical line test is going to pass um, every time. Okay. So it's going to cross in only one spot. Now, because the function is constantly increasing, it would pass the horizontal line test too. So if I turn the line like this direction and I move it through there, now this function is one to one because it crosses in only one spot. That means for every y value, there's only one x value. So it's definitely one to one. And it's onto because the domain and the range are the same thing. See, the domain is all real numbers. Oh, I'm in the wrong tool here. The domain is all real numbers. Remember how we put that fancy R meaning? It could go out to the left as far as you want. You go out far to the right, and you would be able to go and find that line somewhere. It's off the screen there. And off to the left, it'd be off the, it'd be way the heck down here. Maybe we could find it on the screen. But the domain is all real numbers, and the range is all real numbers. It's going to keep on going up forever. It's going to keep on going down forever. So the range is all real numbers. If they're equal to each other, then it's a onto function. And if it passes the horizontal line test, it's a one-to-one function. So it's both of them. So it's the best answer is this one right here. Okay. All right. State whether the function is continuous or discontinuous. That has to do with, could we graph it without lifting our pencil? So if I put my pencil down right here and I just, went like this, I'd be able to graph the thing without lifting my pencil. Now, let's say it had another part to it, and the other part looked like this, open circle here and going in this direction forever. Now it's discontinuous because if I was going to graph this function, I'd have to start way out here. I'd come over here. I'd put an open circle right there. Then I'd lift my pencil up to get down to here. See, I'm not drawing from here to here. I'm just lifting it up, and then I'm going to continue. That would be discontinuous. But that, of course, is not what we had going on here. We had this part right here that's just a function. Now, I know it makes people nervous, like, well, it's not continuing on. It's not, it's starting like right there. That's its starting spot. I know that's true. It's not defined. The domain is kind of restricted here. 1, 2, 3, 4. It's restricted to -4 and everything greater than it. And the range is everything above 0, right? So the range is y values that are greater than or equal to 0. The domain is the x values that are greater than or equal to -4. So you can see that it's not onto, because the domain is different than the range. So kind of coming back to this question up here, it's not onto. It is one-to-one. Like you could draw a vertical line. It definitely passes the vertical line test, so it's a function. Then I could draw a horizontal line anywhere, and it would only cross in one spot. So it's definitely one-to-one. Let me put 1, 2, 1. All right. Well, that wasn't the question, though, is whether it was continuous or not. And it's definitely continuous because I can graph it without lifting my pencil. Okay. Let's see. My next question's on the next slide. True or false? the domain is from -8 to 0. Well, if I look out here, yes, it definitely is starting at -8. It goes over here to -4. But between -4 and -2, there are no y values. I can't find any y values in here. So they're tricking us here. This is not true. It should say -8 to -4. And from -2 to 0. And then it would have the other part. This part is true right here. It is going from 4 to 8, right? So from 4 to 8, because the 4 to 8 part's like right over there. So this was false because it didn't include a gap. There was a gap, and that gap happens right here between -4 and -2. So it's definitely false. All right. Identify which one's linear. This one's linear. I'm going to put a little L above them instead of putting them in that box up there. This one's not linear, NL, because the square root sign is not a power of 1. See, every power has to be a 1 on the X and the Y, and it can't be an X and a Y multiplied together. So this is not linear, even though the powers on the X and the Y are 1s. Now you might say, what about this one? This one doesn't have an X or a Y, but it is linear because Y equals 1/4 is a horizontal line. If you graphed it, okay, so this is the X-axis, this is my Y-axis, the graph would look like this. It would be at Y equals 1/4. It's a horizontal line. So that was a line. This one's not a line because it is a parabola. It's a curve. That's one of our parent functions that we studied in the last section. Not a line here because X and Y can't be multiplied together. And this is a line because this is the same thing as 1/5 X plus 2. I have to divide the 5 into the X and the 10. So 1/5 X plus 2. And this is the slope of the line. This is the y-intercept of the line. Okay, you could just put them into Desmos and take a look, right? Number 5, it says, here's the table. What's the x-intercept? Well, the x-intercept would be the point where the y value equals 0. So if we're going to say this is x and this is y, well, here's the y value that's 0. So this is our x-intercept right there, x-intercept. So it must be 4. And I think they just wanted us to put 4 on that line, not 4, 0. But I do like putting 0 down because it really tells me what to do to find the y-intercept. Well, where is x equal to 0? Remember, x is the first number, right? And y is the second number. So where is x equal to 0? Right here at $7. Well, this kind of got crunched when I printed it out. I think that's $75, isn't it? So yeah, shoot. Sorry, the numbers are going vertically there. So 75 on that line and 4 on this line. Hey, I'm going to pause my video there just in case we have a crash in the video. I'll separate them out. The next bunch of problems will be on video too.